is calling you. The universe is calling me. It speaks both day and night. It's full of dark and light.
Hello and welcome to Sky Tour Radio here on KGRIRadio.com. I'm your host, Mark D'Antonio, here with my co-host, Amanda Curran. Hi there, Amanda.
Hey, all. Hi, Mark.
Awesome. And we both want to welcome you to our inaugural broadcast. But first, I just want to say, I have to thank Rebecca Borneman for her amazing composition and Sky Tour theme song. The Universe is Calling You. That's her song. The music speaks to me. It's a celebration of the universe. And if you really like it, let us know. And if you want to purchase it, we'll be more than happy to point you in the right direction. Now, I would like to introduce Amanda and embarrass her just a little bit. You know, Amanda was a program director on the Mutual Broadcast Network for such shows as Dark 30 Radio and Midnight Express. And she delivered nightly on-air news segments for a number of radio shows. And she's currently the co-host with yours truly on Sky Tour Livestream, our companion live stream to Sky Tour Radio. And as a side note, she's also an avid collector, guys, and she is an expert on all things related to the iconic rock band, The Beatles. And guess what? I don't know very much about the Beatles at all, and she probably rolls her eyes at me all the time when we talk about the Beatles, and I know nothing about it. She knows it all. Now, she was born and raised in Toronto, Ontario, and currently resides in Nova Scotia, Canada. And I think I've done you justice, haven't I, Amanda?
I think that's more than enough. We want to hear about you. That's why listeners are here.
As for me, I'm just your average everyday astronomer. Okay, I have a degree in astronomy. My specialty is exoplanets, planets around other stars. That was kind of where I focused after getting my degree. But I got to tell you a little story. I knew at age 9, I knew that I was going to be an astronomer. I absolutely knew that. And the reason I knew that is because I would look up after going outside in my relatively light polluted skies of Plainville, Connecticut. I went outside, looked up, and I felt homesick. I just felt like, oh, I belong there. Something's telling me I belong up there. I just felt that way. So I always wanted to be an astronaut. I always wanted to learn astronomy. And so I started looking at science books, and then I heard about these things called UFOs, unidentified flying objects, as alien craft from other worlds. Whoa, that was exciting to me. And so a couple years later, when I was 11 years old, I joined an organization called the Midwest UFO Network. And that was in 1971. And it was 2 years after the Midwest UFO Network was founded. Let's fast forward now. Now I'm the chief photo and video analyst for that organization, but it's been renamed to the Mutual UFO Network. That's MUFON, and that's how it's now known. And MUFON's charter is to explore UFOs with a scientific eye, okay? To look for the scientific evidence that they're here. It's the scientific search for the benefit of humanity. And that's what I was all about. And that's why I've been with MUFON since 1971. Oh, man, that really dates me, Amanda. It does make me feel old, I got to tell you. But I try to be the voice of reason, okay? And that's what Sky Tour Radio is all about, the voice of reason. If we're going to look at the possibility that unidentified flying objects are here, then we need to look at the actual factual data that can show that that's not such an unreasonable stance to have. So being the voice of reason is important. And having been the voice of reason for quite a few years, this sort of caught the eye of a number of networks. And I've been able to, participate and asked to participate in shows like NASA's Unexplained Files. And I'm in a lot of those episodes, and I'm in all the seasons of What on Earth. But, I'm not trying to pat myself on the back. I'm just saying this is what happens when you are the voice of reason. What this tells you is that we are actually in an age where people want real information. They want to know real facts. And that's what this is all about, isn't it? Real facts. So this past week, for instance, I filmed in Boston for yet another series that's coming out. And after that airs, I can speak more about it. But as far as me personally, I own and operate a visual effects company called FX Models. I guess that's where you go when you have an astronomy degree, right? Except that I use astronomy every day. And we make giant planets with our Arvada, Colorado connection with Jude and the girls out there that work for me out there. They're wonderful people. And I work closely many times with Douglas Trumbull, who is the man who created the special effects for Close Encounters of the Third Kind, Blade Runner, and dozens of other movies. When I first met the man, I was shaking. I couldn't believe it because I was seeing his work ever since I was a kid. And then I got to meet him. And he's so down to earth, so warm and accepting. And he's also someone who hasn't let his fame and his Academy Awards go to his head. This man says, well, what do you think? I want your idea. And I'm like, my idea? You know, I was a nobody, really. And then he takes your ideas, massages them a little, and you see, wow, that was a good idea. So he was a good guy. So Doug and I are working together on a project called, it's been renamed, but I'll give you the name that you might be familiar with, UFOTOG 2, UFOTOG 2. Now, he created the original UFOTOG, which was an Humvee with these telescopes that come out of on a hydraulic lift out of the top and could examine the surrounding area looking for anomalies in the sky. And it worked, but it was only one vehicle. So one day we were sitting together at the studio up at the movie studio, and we thought together, why not have a situation where we can actually have very small units that kind of did all the same things as your big Humvee. They could be created for a fraction of the cost. And thus the UFOTOG 2 concept was formed, and we got a team of scientists involved, and so now we're working on that. And there's progress to be made, and we'll talk about this in other shows as well. But this is just one of those sidetracks, again, trying to bring science to ufology and explain things in a way that everybody can understand. Now, to that end, I do a lot of conferences. I go to a bunch of conferences. In March, for instance, I think I'm at Hackfort, which is in Boise, Idaho. April, I'm at the Ozark UFO Conference in Arkansas. May, I'm with Bill New York Skywatcher and maybe even Amanda at the Pine Bush UFO Festival in New York State. And then in August, I'm going to be speaking at a conference out in Norway. So we get around, in the name of science. Okay. So because of my love for astronomy and extraterrestrial life, I do run the Sky Tour live stream at John Zach Memorial Observatory. Now, the observatory I built from the ground up. It's a domed building, and it has a nice big telescope in it, which I can operate remotely. And we do this because we want to show the night sky to people who just don't have access to the night sky in the way that we can, and we can show. So we show with very sensitive cameras, we show very faint objects in seconds on the screen versus minutes and hours like some other cameras have to take pictures. And we just do it very quick with our sensitive cameras. All right. And now, along with Sky Tour Livestream, we have Sky Tour Radio. And I'm very humbled that KGRA selected me to do this slot. I'm awesomely happy. And to do it with Amanda is even, that's a double win, right? Don't you agree, Amanda?
I am beyond flattered and humbled that you wanted me to be part of this. I mean, I would have been here supporting you anyway and listening regardless, sending links and stuff, but to actually be on air and to have the trust to, have your back, it means a lot to have that trust. So. Well,
the same can be said for you, obviously. And we got to talk about the motivation for the show. Okay. I've always wanted to deliver astronomy to the masses in a way that was understandable and could leave people with something they could actually talk about instead of just walking away going, wow, that was amazing, and then have nothing to say because they couldn't remember any of it. So my approach here is we're going to try and help you this wonderful KGRA listening audience, help you remember these things, give you some ideas that you can share with other people and repeat. And then maybe you can repeat them to me and tell me some changes or thoughts you had on them. And I'll be happy to incorporate your changes. I certainly don't have an ego to bruise. I don't have any ego whatsoever about all this. I'm very happy to listen to other people. Because again, I think that as part of the motivation, science is within reach of everyone, and it should be. All right. You should not need an advanced degree to understand astronomy or the universe. Nor should you just be a parrot repeating things you may not understand. Like, oh, hello, I'm Carmen. I'm a parrot, and the universe is huge. I mean, you don't want to have to be that. You could understand it. So on this show, future shows, we're going to talk about the universe, and we're going to focus, of course, on extraterrestrial life for a good deal of time. It is the topic of my book, The Populated Universe, and I did that because, I believe in it strongly. We'll talk about the history of everything, which is Amanda's favorite topic, I believe. Correct?
That's basically how we met, and I think
yeah.
I think it was kind of the premise for the YouTube show. I mean, a lot of people seemed interested in the idea, and like I said, to have an expert to break it down, so it's not just like, that sounded amazing, but I'm not really sure what he said, or just parrot back a few lines without having any meaning behind it. That's appealing to everybody. And you do it for free, and you take questions and you take calls. I mean, it's so needed. It is so needed.
Well, I'm glad you think so.
Appreciate it.
I'm certainly not. I don't have knowledge of everything, of course, but when I joke about telling the history of everything, because that implies I know everything, and of course I would never ever say that. And you can ask Amanda behind my back, and she'll tell you the same, that I'm not really someone who thinks I know everything. Okay, but it's nice to be able to give people a foundation for what's happening here on Earth, how we're here, what is important about the Earth versus other planets elsewhere. Very important stuff, and we're going to tackle that. We're also going to tackle things like, especially if you believe that, as I do, that extraterrestrial life exists, and that perhaps some of it has reached intelligent levels, perhaps thousands of years before us, and is here. If that's true, we have to talk about interstellar travel and how it's even possible. And we're going to do that. And this will actually relate to our UFOTOG-2, or the Aerial Anomaly Detection System that we talked about, because that system has sensors to detect an advanced race that's utilizing an advanced propulsion technology. And we'll talk about that again. But the other thing we're going to do in future shows, and even this show actually, is we'll take questions from the chat where there's time, and an occasional call. But we are going to have guests on from time to time. Because as I said, I don't know, I certainly don't know everything, and I don't profess to. But I do have, a small amount that I understand within astronomy. I can handle that. But we also have to have some guests on that have different specialties that are ancillary or related to mine, I think, because then we can talk about how my technology would blend with their technology, and maybe there's a synergy there that we'll all find. And I implore the KGRA audience to do the same. If you have suggestions for us, please go right ahead. You'll find that I'm very reachable and actually very responsive. I'm certainly not, one of these people that never answers an email or anything. I look forward to hearing from you guys. So thank you for joining us, and now we'll move onward because the universe beckons. Agree, Amanda?
Agreed.
Yeah. So I think the first thing we want to talk about is, again, this relates to the universe. When we look up at night and we're outside, we're actually seeing a grand universal time machine. And I know that some of you out there listening know exactly what I'm talking about. Okay? The stars are not 2D on a flat sky, but are in 3D space. And you've seen videos where when you approach the stars, like the Big Dipper, for instance, changes the way it looks tremendously. All right? That's the truth of the universe. But another truth of the universe is that everything is in motion. Nothing is sitting still. There is nothing that isn't moving. And we're not talking about slowly moving. Everything's moving fast, okay? The sun, for instance, goes around our galaxy let's see, it goes around once every 230 plus million years. It's gone around just about 20 times so far since the Earth was formed. So, everything is moving. So if we consider, for instance, that when we look at the sky, now I mentioned also we're looking at 3D space. That implies something else. That implies that we do have this time machine. Everything we see, every star we look at, is actually seen at a different time. We're seeing it at some point in the past. And I think you understand that. Everybody understands that kind of implicitly, but I'll just go a little bit more. The sun is seen 8 minutes in the past. All right. At the speed light travels, it takes 8 minutes for the light to actually get here from there. And we'll be talking more about that. The Big Dipper stars. Everyone's familiar in the Northern Hemisphere with the Big Dipper. It circles the North Pole, and it's a group of stars inside the constellation of the Big Bear, the Great Bear, Ursa Major. Now, the Big Dipper stars look like they're just, 1, 2, 3 stars in the handle, and then these 4 stars in the ladle or cup of the Big Dipper, but they're all at different distances, And if you remember that ladle or that cup in the Big Dipper, the one farthest away from the rest of that constellation's stars is called Dubhe. It's up in the corner. And you can see it. It's the most prominent one at the lip of the cup. And that star is 195 light years away. That is to say, it's 195 years in the past that we're seeing it. And it's taken its light 195 years to get here. So the funny thing is when you look at it, you say, wow, the light that left that star took 195 years to get here. What was happening here 195 years ago? And you go back and look in our history and say, wow, 195 years ago, this happened or that was happening, okay? And we can do this and see that there are some places in the universe that we look, and when the light left those things to get to us, the entire planet was molten and had yet to form, fully. So that's how far back in time we can see when we're looking in the universe and beyond. I mean, we can see back to before the Earth was even formed, So it's incredible. Now, so the Big Dipper alone is an example of how all the stars are at different distances and how it's sort of a time machine. And we'll talk about stars in detail in future shows, but I got to say this: it's a dangerous, unbelievable, and mind-bending universe, and we're going to try to bring it all to you, any way we can. Now, for the next thing, we know that it's a time machine, but we know that the stars are at different distances. But how big is this universe? How big is it? All right. We know the age of the universe. We know it's around 13.8 billion years old. But what's the size of the universe? And that's something that's interesting. And it comes down to scales. And I'm a model maker, a visual effects guy, astronomer, and I make scale models of the universe a lot of times. And so let's begin with the Earth. The Earth is 8,000 miles in diameter. All right. That's the real size of the Earth, 8,000 miles. Doesn't sound like a lot, I realize. But that's because we don't travel through the Earth. We travel around its surface. And to go around its surface, all the way around, is 24,000 plus miles. So, but it's 8,000 miles if you want to cut through the center. Now, moving state to state or country to country, we know how much time that takes as human beings. It takes us a while, right? And crossing the ocean was the equivalent of going into Earth orbit for the ancient mariners, right? I mean, there were many risks, I mean, Amanda, you remember we've talked about this where ancient mariners would have a fear that they would drop off the edge, right?
Yeah, and also for the unknown land, they draw like monsters and stuff.
Exactly so.
On the old maps, yeah.
Yeah, and why did they draw those monsters, do you know?
Well, they didn't know, or maybe people didn't come back, or I don't know the history of it, but I do remember seeing them and thinking, did they actually believe that at the time? And I guess they might have. That's
right.
Interesting to look back.
I think you're right. And now But of course they didn't drop off an edge because there is no edge because Earth isn't flat. And don't worry, we're going to address that whole thing in another show as well. The whole quote unquote flat Earth concept.
Yeah, I look forward to that.
Oh yeah, we're going to have fun with that one. Okay. Now, and there's a particular reason that Amanda's going to look forward to that, which I'm not going to tell everybody right now. Yeah, but we'll say it when it's actually that particular show.
That was our first meeting.
Yeah, it's sort of our first meeting. That's right, and it wasn't too pleasant. But and that was my fault, though. That was my fault. Now we understand the Earth is the certain size it is, but we're out in orbit now. We know that we've made this International Space Station. The space station takes 90 minutes to go around the planet. It's several hundred feet long. It's made with these tubular constructions all interlocked together. And it has these wonderful gossamer solar panels that if they even dipped into the atmosphere for a short amount of time, they would be torn away and shredded. But it's still traveling. It's in orbit about 252 miles above the Earth. It still travels 17,500 miles an hour. And there's a wonderful video of it crossing the sun that somebody took. And you see it. It crosses the sun. It looks like a bug flying across the sun. It moves so fast. Yet you're watching a human-made construction 252 miles away go blazing across the sun as fast as possible. Because it was, of course, in silhouette against the sun. Certainly not near the sun. But it really was something. And the astronauts on the International Space Station, they see sunrise 16 times a day and sunset 16 times a day. I mean, what a day, huh? A 90-minute day? Wow, And they see it 16 times.
16, yeah. I was thinking 15. 16 sunrises.
In a 24-hour period, yeah. Yeah, it's pretty cool.
I see, I mean, do they... It's kind of off topic, sorry, but
No, it's all right.
Astronauts even get training for that? How do they, I mean, physically it might not make a difference at first, but just to wrap your mind around that, how would you get used to preparing to experience for something like that? I think that would just be too surreal for me to function, do spacewalks the next day,
I think you just have to learn how to leave your jaw dropped in a gape and just have a dumb look on your face, because I'm sure that's how it's going to feel seeing sunrise from space and sunset from space just a short time later. So
but in zero gravity, would your jaw not go back up?
That's correct. See, you're thinking. Okay, and the thing is, if you relax in space, your body just comes to a rest at whatever position you're in. And so looking at astronauts sleeping is hilarious because they're in all these positions that look like they'd be painful under gravity. But in zero gravity, it's the most comfortable thing in the world. It's like a sensory deprivation tank where you're floating in water with earmuffs over your head or whatever, and you got your eyes covered. You can just imagine in a quiet spot on the space station, you would actually feel that. It's amazing, So let's get away from the Earth for just 1 second, though, because I want to just run through one more thing before we have to go to our first break in a little while. I want to talk about now the scale of the universe beyond the Earth. So let's talk about just our solar system. We have the planets. We have Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and arguably Pluto. Okay.
I was wondering how you were going to end that sentence.
I know you would. Okay. But we need to appreciate the size of our solar system, I think, to understand just how big the universe is. So let's start. Let's first of all consider that I actually wrote a program on the computer here just this past week to calculate the size of the solar system if we made it a scale model. All right. So the scale model would go from the sun out to Pluto. Now, Pluto is 4.6 billion miles away. Okay. That's a long distance. All right. Now, we sent the New Horizons space probe out there, and New Horizons took 15 years to get there. All right. So keep that in mind as we move forward, everybody. Okay. New Horizons took 15 years to get there. Now, if we consider that the sun is 865,000 miles in diameter, that's a massive star, right? It's a lot bigger than the Earth. In fact, you could put over 100 Earths side by side across the face of the sun. That's how big that is, okay? And just so you know, the sun is considered an average star. Not too big, not too small. Okay? That's an average star. Wow. The universe has a whole lot in play for us, let me tell you. So we'll learn about some of the bigger stars in different shows as well. So now, so check this out. If we shrink that sun to a ½ inch in size, okay, Mercury would be 2 feet away at that scale. Venus would be 3.8 feet away, just on the inner edge of our habitable zone. Okay, Earth would be 5 feet away. Mars would be 8 feet away, just on the outer edge of the habitable zone. That is the zone that's not too hot, not too cold. And then if we look at Uranus, all right, Jupiter's 28 feet. Okay, Saturn would be 51 feet. Uranus is 102 feet. Neptune 161 feet. And Pluto at the far end would be 211 feet away from our little ½ inch marble. Okay, that's a little ½ inch marble. Now, keep in mind that it took us 15 years to get to that little ½ inch, to that little marble from to Pluto, 211 feet away, because it's 4.6 billion miles away in real size. All right, but now consider, what about the nearest star? The nearest star system is Alpha Centauri. All right, it's a triple star system, but we'll get to that. Consider
after
that
the break. I hate to do it to you. We'll have to get to that after the break, though, because
I suspect. I mean, we have a break coming up. I'm not sure. I haven't seen notice of it yet, but I'm sure we'll have one soon. I have.
Yeah, it's coming up right now. So hold that thought, please.
We'll be right back then.
Mother hen stepping in.
Thank you.
Stay tuned for the rest of the conclusion of The Size of the Solar System.
Hey, welcome back to SkyTour Radio. I am.
This is SkyTour News for January 28th. I'm Amanda Curran. On this date in 1912, Goddard begins liquid propellant rocket research. After 3 years of unsuccessful tests, showing smokeless powdered solid fuels were too unstable for rocket use, Robert H. Goddard turned to liquid oxygen and gasoline as propellants. On this date, he bought his first 2-gallon flask for $10, the minimum amount the Linde Corporation in Worcester would sell him, as the liquid form was then only a byproduct in the process of extracting gaseous oxygen from the atmosphere. Today in 1960, NASA presented their 10-year plan to Congress. In testimony before the House Committee on Science and Astronautics, Richard E. Horner, Associate Administrator of NASA, presented NASA's 10-year plan for 1960 to 1970. The essential elements had been recommended by the Research Steering Committee on Manned Spaceflight. NASA's Office of the Program Planning and Evaluation, headed by Homer J. Stewart, formalized the 10-year plan, where a lunar soft landing with a mobile vehicle had been added for 1965. Today in 1986, the Space Shuttle Challenger disaster. The NASA Shuttle Orbiter mission STS-51-L and the 10th flight of Space Shuttle Challenger broke apart 73 seconds into its flight, killing all 7 crew members, which consisted of 5 NASA astronauts and 2 payload specialists. Disintegration of the vehicle began after an O-ring seal in its right solid rocket booster failed at liftoff, causing a breach in the SRB joint it sealed. Aerodynamic forces broke up the orbiter, and the spacecraft disintegrated over the Atlantic Ocean off the coast of Cape Canaveral at 11:39 a.m. Eastern Standard Time. I'm Amanda Curran, SkyTour News.
Hey, welcome back to Sky Tour Radio. I am Mark Antonio, and this is Amanda Curran. Say hi.
Hi.
There we go. And when we left off before, we were talking about the scale of the solar system. If we made the sun a half-inch in size, our solar system would be 211 feet out to Pluto. All right. If we just go to the planets and not talk about the Kuiper Belt and the Oort cloud beyond.
Just our solar system.
Yeah, exactly. Let's just talk about the planets and the ex-planet Pluto, of course. Okay. You can imagine, I tend to think that Pluto probably should be considered a planet because classically and culturally, it's a planet. Even though it might not technically be a planet, it's actually more of what we would call a trans-Neptunian object. But don't worry about the terms, okay? Just understand, in our scale where the sun's made down to a half-inch in size, Pluto would be 211 feet. Now the question is, at that scale, how far is the nearest star? And the nearest star, of course, is Alpha Centauri. And that's the triple star system that consists of, star A and B, which are kind of like the sun, and then C, which orbits both of them at a much greater distance, which is a small red dwarf named Proxima. And by the way, we have a planet we found around Proxima, just so you know. So the closest planet to us besides all of our solar system planets is at Proxima Centauri in the Alpha Centauri system. So how far away is Alpha Centauri at our scale where Pluto's 211 feet from our half-inch marble, which is the sun? The answer is astonishing. It's 274 feet? No, miles. In our scale model, if you can imagine, take a car moving 60 miles an hour. Pluto at 211 feet would be reached by, only 2.4 seconds would elapse. Alpha Centauri would be 274 miles away and will still take 4.5 or 5 hours, depending on traffic. Out in space, I don't think you'll get traffic. But think about that. 2.4 seconds to Pluto versus 4.5 hours to Alpha Centauri. Now you see the scale of the stars and the distance of our stars from us. We're isolated, yet we're not. We're in a fairly robust area in the galaxy where there's a lot of stars, which we're going to talk about momentarily. But let's talk about this. If you think it took long to get to Pluto at 15 years, let's take the fastest space probe ever, much faster than the New Horizons probe, Juno, Juno. That's the probe that actually is circling the poles of Jupiter and it's providing these unbelievable suites of data. It moved at an astonishing 165,000 miles per hour. And at that unbelievable speed, it still would take 17,400 years to get to Alpha Centauri. So you see, this is what we're up against. We're up against a universe that has tremendous gulfs between the stars. Yet we look at it and say the fastest speed that we can ever travel is something close to light speed perhaps, but not light speed itself. And that makes you think, well, then I guess we'll never actually get to the stars, right? Yeah, I don't think that's true, because we've also learned some other things about the universe that we're going to pursue later on in other shows, which is going to talk about interstellar travel and how it's actually possible. And I'm not talking generation ships where the people that leave on the trip are not the people that arrive, but their offspring and generations beyond them. I'm not talking about that. I'm talking about being able to get to Alpha Centauri in just a matter of a few days or a few weeks. All right. And that technology does, potentially exist. And NASA's actually funded a lab to look at that technology. So that's how serious they take it. And that's a teaser for the next potential show. Now, when we talk about Alpha Centauri being 4.3 light years away, I just want to clarify, what do we mean by a light year? Well, first of all, in our universe, regular units really become useless pretty quick. A light year is the distance light travels in a year. And that's a convenient distance measurement when we're talking about nearby stars, perhaps, because 4.3 is a much better number than 28 or 25.8 trillion miles. Okay, so if we look at in light years, it's 4.3 light years to Alpha Centauri, In miles, that's 5.8 trillion miles per light year, okay, times 4.3. And now you can see how very, very quickly the units become meaningless. So we figured, well, let's use light. How fast is light? Well, it's pretty darn fast. In 1 second, if you could arrange it with mirrors all the way around the Earth so that a laser beam could be reflected all the way around the Earth to come back to the same point it started from, in 1 second, that laser beam would go around the Earth 7.5 times, just about. Can you believe that? 7.5 times around the Earth in 1 second. That works out to about 186,000 miles per second. The actual number is 186,282, but who's counting? It's just a number. But that's miles per second. That's what's important. But even at that astonishing speed, it still takes light that 4.3 years to get here from the nearest of the stars. And there are billions of them. Now, I do want to quickly just give a shout out to Martin Willis out in the chat. Martin, thank you so much. I also have anxiety about Pluto not being a planet any longer. But you know what? We're working on it, man. We're working on it. We'll see what we can do, right? If we all voice it, I think that perhaps someone will listen. And then they'll say, stop inciting riots, get off the radio. And that'll be the end of this. But let's now look at these billions of stars. Let's talk about these for a minute.
Actually, our good friend Martin had a question.
Awesome. That's a good time to ask.
Yes, and I guess we will be taking questions throughout the show. So if you have them in chat, please send them. I'm DannyFan1 in the chat, so I'll definitely keep my eyes out for them.
Thank you, Amanda.
Martin wants to know, do galaxies travel at different speeds?
And the answer to that is yes, they do. Now, and it'll take a little bit of understanding to talk about what galaxies are, and I'm actually just about to say that, which I think is kind of a cool segue, Martin, and I want to thank you for that. Galaxies generally will form in clusters. There are clusters of galaxies. We're in a local cluster of galaxies, and then there's a local supercluster of galaxies, and then there's more clusters of galaxies. And within the clusters, they all kind of move around each other, toward each other, through each other, okay, doing what are galactic collision, okay, but even this galactic collision is something that would probably go unnoticed if the, say, Andromeda galaxy, which is heading for us, 2 million light years away, heading for us, passes through us, because it's not like there's anything to crash into in a collision. So because the star separation is as it is, like I mentioned, like you saw with the Alpha Centauri analogy, most likely we wouldn't even notice that it went through. We would just see a different sky, every now and then, and say, "Oh, look, the stars are a little different." If it was millions of years later, then we would notice perhaps that the sky was significantly different. Maybe there's 2 Milky Ways because the Andromeda galaxy would form one Milky Way and our galaxy would form another Milky Way, and maybe that's the far future, But they all do move relative to each other and at different speeds, indeed. And it has to do with their gravity, their mutual gravity pulling on each other, whipping them around each other. There's so many features in the universe that we should talk about at some point that relate to that. It's amazing. Now, what is a galaxy? Well, a galaxy is a collection of, obviously, many stars. I like to call them island universes because that's kind of what they are. They're little island universes out in space with stars that circulate around a core of a galaxy. And they have between 100 and 400 billion stars, in our galaxy. But in other galaxies, like in the Andromeda galaxy, there's up to 1 trillion stars. Again, a number that just is a big number, and you can't even imagine a trillion of anything. But still, the Andromeda galaxy is massive, okay? And the stars orbit the galaxy. I mentioned earlier, our sun takes 230 million years or so to orbit our galaxy, and it's done so just about 20 times since the birth of our Earth 4.6 billion years ago. All right? So, it's a slow-moving pinwheel, basically, if you want to think of it that way. But there's at least 2 trillion galaxies out there so far. That number, sort of keeps going up because we actually can get information from the Hubble Space Telescope that tells us that, which I'll mention shortly. But with 2 trillion galaxies, there's plenty of chances for life. And in each galaxy, according to our current estimates, we could have between 15 and 20 billion habitable worlds in our galaxy at the low end. And at the high end, we might have as many as 40 billion habitable worlds just in our galaxy. And then when you consider that there's 2 trillion galaxies out there, now you see why I titled my book The Populated Universe. Because I believe that it's definitely a universe that is teeming with life. Because, my premise is life is the rule, not the exception. And I know a lot of you agree with that out there. I know that. Now, when we talk about the galaxy as a whole, that's one thing. That's a massive conglomeration of stars that's very, very large, hundreds of thousands of light years across. But the universe itself is so much bigger. It makes our galaxy look like a tiny speck. And you got to say, well, where are all these galaxies that we see? Well, they're in the universe, of course, but what we call it is the observable universe. That is the universe we can see from the Earth. All right. So how far away can we see from on the Earth? Okay. We can see objects, in the observable universe to the limit of our technical ability to visualize them with a telescope or what have you, or a detector to detect their radiation when there's nothing visible. And that's important too. But the universe is expanding, and everything we see is running away from us, except for galaxies and clusters. I mean, if we're in a galactic cluster, a supercluster of galaxies, and our local cluster of galaxies. And those galaxies all sort of move around each other and everything. But as a whole, that cluster is moving away from that other cluster over there, for instance, that's a lot farther away from us. Okay? They all appear to be moving away from each other. How could that be? We're not at the center of the universe. If we were, then yes, they would all be moving away from us. We'd be right at the very middle. But that doesn't make sense. What are the chances? Not good. So what is it? Well, there's an analogy that I think will help. If you take a balloon and you start to blow it up, blow it up, get it to about the size of, say, 4 to 6 inches, and then you start putting black dots on the outside edge of the balloon, right, all around the balloon. Just put black dots on it. And then put one dot on it that says, okay, that's going to be our galaxy, and then or our galactic cluster. Then you put a few dots around that one. All right, and you measure the distance. You'll say, okay, well, on this balloon that's blown up to 6 inches, that distance is, say, about 3/4 of an inch, okay, or say 2 or 3 centimeters maybe. Then you blow up the balloon more. And if you remeasure, you'll find that every single distance has increased because everything on the surface of an expanding balloon is moving away from everything else. Now, there's something for you. Think about that. And that's how our universe is working. So we're not at the center, all right, but we are out there somewhere. And finding the center of the universe is really a tough thing. I mean, that's like watching a football game with all the players running downfield and then trying to work backwards and say, well, where did they start from if you never saw them? If you never saw where that all started, you don't know how far back they were. You don't know where the kick was received and then started to be run back. You have no idea. So that's what we're up against with this. Now, we know that the age of the universe is 13.8 billion years old. Okay? We know that. We've been able to figure that out. Now, what is the size of that observable universe? Well, you would say, well, hey, 13.8 billion years old, we can see out to 13.8 billion light years. Well, doesn't that mean that the universe is at least, 13.8 billion light years in size? And the answer is yes. That's true. Okay. But the Hubble Extreme Deep Field in 2012 was an image they took showing galaxies fully formed out to a distance of 13.2 billion light years. Now, why is that an important value? And what do we care about this? Why is it important, this extreme deep field? It's important because it shows that we had fully formed galaxies that far back. All right. And if we think the universe was 13.8 billion years old, and you'll want to know, like, well, why 13.2 versus 13.8? I'm confused. Well, 13.2 billion years is the distance of objects that make sense to us, like galaxies, okay? But 13.8 is the distance to something called the cosmic microwave background. It's the background radiation that seems to be present, that was present right after the Big Bang occurred. All right? So that's why we look out there and say, we think the universe is 13.8 billion years old. The question, though, is, since that light from those 13.2 billion light-year distant galaxies has been coming to us, the universe has continued to expand. So by the time that 13.2 billion-year-old light gets here, the universe is much bigger. All right? So what is that size? Well, as that light streamed to us and the universe expanded further during that time, it got out to almost 47 billion light years based on expansion rates and other factors. And that is a radius of our observable universe. That means from Earth to the farthest point we could see, we expect that would be 47 billion light years by the time that light reaches us, okay, which it hasn't yet, all right? So that means that in diameter, the actual observable universe is 93 billion light years in diameter. That's our observable universe. This is stupendously colossal, and it's stupendously colossally massive. All right. So now you ask, well, wait, what's beyond the observable universe? More universes, perhaps? Oh, what about beyond that? So if there's more universes, there's a theory that I subscribe to that I think is important, and I'm going to talk about a thing that happened to me that is really odd, and I'll sum it up for you. But and it relates to parallel universes. If there's more universes, then imagine this: you have a bowl in the sink, and you put in some dish soap, and you run hot water in there really rapidly. Really get it in there, fill it right up with suds. If you look closely at those suds, what do you see happen? Well, you see some of the suds vanish and pop and disappear. But if you look really closely at the shape of those bubbles, they're not round, are they? They're not just round bubbles like you see in cartoons. No, they're faceted. They have faceted sides, some flat, right? And they're all like, and the ones in the middle are bordered by other bubbles. And so they have very, relatively sharp edges, right? Well, guess what? What if that is the universe theory that we should be looking at? What if the parallel universes are arranged this way, as a froth, as a mass of bubbles, the soap suds, universe, so to speak. Now, frothy suds can have thousands of bubbles and sub-bubbles, and is this what we mean by a parallel universe, or a multiverse, the multiverse concept? Well, I don't know if multiverses are real. I can just give you an example of what happened to me. And Amanda, you remember my story about in my shop, right?
I love this story, except the ending. But
yeah, but there's no pain was given. So
I think it would have led to a different result, but I still love the story. So go ahead.
Well, I was okay. The weird thing is I didn't know what this was. So here's what happened. I was working on a special effects model for Doug Trumbull. We were doing a movie. And it was our movie. It was called it was the Ufotog movie, actually, that actually was sort of a kickoff movie for our new technology we developed for doing 3D movies at 4K at 120 frames per second. It was a brand new technology Doug developed. It's just beautiful. Ang Lee used it in The Long Walk of Billy Lynn, and that movie, and a couple other big name producers are considering using it for some very, very high power sequels. Well, bottom line is, I was working on a prop for that movie, something I was having a ball doing. It was 3:30 in the afternoon, and I was working on it, and all of a sudden I saw this this is going to sound weird. I'm a science guy, guys, and this doesn't happen until it does, okay? It doesn't happen to me, all right? And I don't know what to do with this, so I'm just telling you. This I had been seeing people that weren't there and hearing people talking that weren't there for about a year ahead of time. And I'd say about 24 years ago, I had brain surgery to basically save my life. Okay, I was going to be dead within weeks if I hadn't had this surgery. So they managed to save my life. And so it was sort of a fast surgery. It came up in a couple of days. And the technique they used to get this thing out of my head was, I don't know, Dr. McCoy from Star Trek would say, they're barbarians, Jim, But the fact is, they got it out, saved my life. And so I thought, as the injury matures, maybe something would happen in my brain. So as I was sitting there brushing my teeth one day, I saw out of the corner of my eye, I looked back behind me, and there was a woman standing there, semi-transparent. She looked like she was made of water, but without the shine. Well, anyway, this led to this incident in my shop where a dog walked in, semi-transparent dog, and it curled up on the floor, and I'm staring right at it. And I got up, and I walked over, and I looked at it and realized, wow, I can see the other side of it. So my theory was that my brain was replaying events that it had seen. And if that's true, it shouldn't have been able to see the other side of the dog unless I absolutely had gotten up at the time I saw this thing originally and saw the other side. But that's not what was happening, I didn't think. So I did something I just never imagined I would do. I stepped into space being occupied by this little semi-transparent kind of dog thing. And what happened next changed my world, because instead of it being a medical thing that I thought was related to my surgery, I found out, in my mind anyway, that this was something far more, what's the word? I guess far more important or far more deep. Okay. As I stepped on it, it registered that I stepped on it, and it got up and it ran out of my special effects shop. As it did so, it took my foot with it. And you have to imagine a bungee cord being wrapped around the base of your ankle, or the base of your foot, actually, right on the ground where you're standing, and someone taking it and running as fast as they can away from you. You can feel the tension increase. You can feel the elasticity, getting thicker and more taut. And it's like, oh, my foot. It's getting harder to hold your foot down. Next thing, and that's how I felt. And the next thing that happened, my foot just shot out from under me. And it flew right up to the ceiling. I saw the lights. I saw my foot. I was tossed right on my back, right up. And I saw my other foot go up too. And it landed right on the back of my head on a concrete floor in my shop. I was stunned. I looked at that and I said, wow, that's amazing. I'm running around the shop going, did you see that? Did you see that? To myself. There was nobody there except me. So anyway, and I'm just telling you like it is. I mean, I've told the story before, and I've never added embellishment because embellishment doesn't work. Okay. For me, it doesn't work. You either tell it like it was or just don't tell it at all. So that happened. And I realized, I think that was rudimentary communication with a parallel world. That's what I think I saw and experienced. And I was beside myself. And when I went up with the prop to show Doug Trumbull, I told him the whole story, and he looked at me and he says, yeah, you don't drink, do you? I go, no, of course I don't. And you don't smoke the funny weed. No, Doug, I don't do any of that stuff. So he's kind of looking at me and going, well, he goes, the universe is a really interesting place. I go, yeah, that's what I'm thinking. And I think I just had rudimentary communication with a parallel world. And what do people do when you tell them that? I mean, even people that believe some of that, it's like, well, you don't have any proof. Why didn't you pull out the camera? And I asked myself, yeah, why didn't I? So I've been waiting to, I've been trying to get to pull out the camera at times when I see things happening, but it just it doesn't happen. So I got to tell you guys, I'm really, I'm incredibly happy that I have the forum to talk. And I don't know, Amanda, I know we don't have a whole lot of time left, but is there anybody that has questions? I could answer a question real quick, maybe, but.
There was the question. I just wanted to say, I think this is why we need a show like this, because even your analogies of shrinking the sun to half an inch, and we so quickly go from feet to miles and then light years, it gets so overwhelming. So I'm so glad that you are taking time out of your busy schedule to break it down for us into, bite-sized portions that we can wrap our head around. And I think tonight was a wonderful basis to start with and add to. We did have a question actually from our good friend Kathy. She wanted to know, weren't galaxies identified as such during the 20th century? Maybe you can touch on when the Hubble telescope or the new one's coming out, and
the James Webb will be out in 2018, and I do think we're going to have to wrap here pretty quick, and I can take that up, I think, on the next show if we remember, if Kathy's going to be here. But I did want to tell you that I'm really, really pleased for the opportunity, and I just want to thank everybody for listening to our show, for our first inaugural show on Sky Tour Radio here on KGRA. Thank you all, and I look forward to seeing you all again.